Hello student, today we are going to see NCRT class 9 physics problem solution we are going to see. 8th chapter first problem, motion chapter, all the example and exercise problem we are going to discuss. Okay. First we will see this question 8.1. Okay. For problem solving, now first of all you should understand what is a given data. Okay. The given data is, see here, 16 meter is a 4 second and it is a 16 meter in 2 seconds. Okay, now they asked about average speed. Okay, so it's an example problem, 8th chapter first problem. Okay, 8.1 we are going to do. Okay, if you like my channel, please subscribe. Thank you for watching my video. Okay, first what they are given, 16 meter in 4 seconds, again 16 meter in 2 seconds. Okay, now we'll do this problem. So average speed is the total distance by total time period. What is the total distance? 16 plus 16. Okay, so 16 plus 16 what will get? 16 plus 16 will get us 16 plus 16 32 by 4 plus 2 will get 6 32 by 6. Okay, now we'll do the division for this problem. So 32 by 6. Okay, so 32 by 6, 32 by 6, so 6 5s are 30, again 2.0, 18 will be 3 times. Okay, the answer is 5.33 meter per second. Okay, now I'll go with the second problem. Okay, example second problem we are going to do now. Okay, see here, it is second problem is given about odometer. Okay, odometer means so in car it will be there, no speedometer, that only. The trip is started from 2000 kilometer and when it's in 4000 kilometer, the total journey time is 8 hours they are taken. Okay, it's a very simple problem. This is a solution. This is a problem we are going to do the solution now. Okay, it is an example problem, 8th chapter second problem. Example problem, 8th chapter second problem. Okay, what is a starting kilometer? 2000 kilometer odometer is shown and end with 2400 kilometer. What is the time taken? No, 8 hours. Okay, so total journey distance is 400 kilometer. Okay, time period is taken 8 hours. Okay, now speed is distance by time. Distance is 400 kilometer, time is 8 hours. Okay, so if you are cancel this, no, two tables, so it's a 200 divided by 4. Again if you are cancelling, no, 100 divided by 2. Again if you are cancelling, 50 kilometer per hour. Okay, the problem you should give in a SI unit only. Okay, so 50 kilometer, no, 1 kilometer is 1000 meter, 1 hour is 3600 second. Okay, 0 get cancelled. Okay, 500 divided by 36, normal division only you can do. Okay, you will get answer. Okay, so the answer for second problem is 500 divided by 36. 500 divided by 36. Okay, 500 inside, 36 will be outside, 36 will be one time. Okay, here 4 will come, here just a cancel, 4 will come, here 1 will come, 140. Okay, so 136 into 3 times, 36 into 3 times 18, 9, 10. Okay, so 108 I will get as a 3 times. Okay, now so 3, here 3, 10, 2, 32.0, here you will get. Okay, so approximately the next number 9 times, 36 into 9 will get some value. The answer is going to be 13.9 meter per second. Okay, or we can call as 50 kilometer per hour. Always you try to give with the SI unit. Okay, this is the correct answer. Okay, now I'll go with the third problem. Okay, yeah, 8.3. This is a problem we are going to do now. Okay, the problem is based on the distance and displacement, speed, velocity. Okay, Usha swims in a swimming pool. She's swimming pool diameter is a 90 meter. Okay, the totally she covers 180 meter in 1 minute. Okay, end to end she went forward direction and came back to the same position. Okay, now we'll do this problem, third problem. Okay, first of all you will try to understand the question, what is given in a question. Okay, the question is given, it's 8th chapter third problem, example problem, 8th chapter third problem. What is question is given? It is the Usha swims in a swimming pool. It is a 90 meter. Okay, swimming pool dia is 90 meter. Okay, so when she goes and come back, no, distance is how much? Distance is actual length of the path. Going is 90, coming back is 90. 90 plus 90, 180 meter as the distance. What about displacement? Displacement is equal to 0 because starting and ending is the same. Okay, now speed is distance by time. What is the distance? 180. Okay, she's taken to cover with 180 meter as how many minutes? No, she's taken as 1 minute. Okay, so the time is 1 minute she's taken. No, in second 60 seconds we can call. Okay, 180 by 60 meter per second, cancel 3 meter per second, it's going to be a speed. Okay, and again velocity. What is the velocity formula? Velocity is equal to displacement by time. Displacement is 0. 0 by 60 will get us a 0 meter per second as a velocity. Okay, now I'm going to do with the fourth problem, example 4. Okay, now fourth problem, example, it is a 8th chapter 4th problem we are going to do. Okay, I'll show the question now. It is a 8th chapter 4th problem. It is a bicycle, start from rest. Okay, so the Rahul pedals a cycle, it start from the rest. Okay, it start from stationary position. So that means what is the initial velocity? 0. He reached 6 meter per second in 30 seconds. Actually this problem is based on two conditions. First we'll solve first condition, then we'll go for the next condition. Okay, so what is given now? First condition alone I'm going to do. Start from 0. What is the initial velocity? 0. What is the final velocity? He is reaching 6 meter per second. What time is taken? Is taken with 30 seconds. Okay, now they asked about acceleration. Okay, acceleration is equal to v minus u divided by t. V is how much? 6 minus 0 divided by 30. 6 by 30. 6 by 30, 1 by 5. What is 1 by 5? 1 by 5, 0.2. Acceleration unit we can call as meter by second square. Okay, now so like this graph you are drawing now, it is easy to understand. Velocity versus time, the acceleration increasing from 0 to velocity increasing from 0 to 6 meter per second. It is a first off. Okay, it's happened with the 30 seconds. Okay, now he is going in a 6 meter per second, he reduces velocity, applies the brake. Okay, he now reaches a 4 meter per second from 6 meter per second. His velocity getting decreased now. Retardation, second half of this problem, retardation. Okay, again they asked what is the retardation. Actually already I told you, no, there are two conditions is there in this problem. I'll show the question again. See here, see the question is telling second it's reached with the 4 meter per second with 5 seconds. Okay, so the velocity decreases from 6 meter per second to the 4 meter per second. So what is the initial velocity? Initial velocity 6 meter per second. It is the second condition. V is equal to how much? 4 meter per second. For doing this process is taken as a 5 seconds as a time period. Now retardation. Acceleration is equal to V minus U divided by T. V is how much here? Final velocity 4. Initial velocity 6 times taken 5. Minus 2 by 5. 2 by 5 how much? 0.4. So retardation is minus 0.4 meter per second square. Okay, so the acceleration is how much in this problem? Acceleration is 0.2 meter per second square. Okay, when the velocity is increasing, the second half the velocity is decreasing, minus 0.4 meter per second square. It's called retardation. Okay, now I'll go with the fifth problem. It's a example problem, fifth problem now we are going to do. Okay, it is a motion chapter, example problem, 8th chapter, 5th problem we are going to do. Okay, I will show the book what is a given data First of all, when you are trying to solve the problem, you will take the given data, then you will start solving the problem, okay, and find out the suitable formula, okay. The train start from rest. Start from rest means initially 0. Reach with 72 kilometers in 5 minutes, okay. They want acceleration and displacement, okay. This is a question is given. So I'll write whatever is given. Start from rest, initial velocity 0. Start from rest means initial velocity 0. Stops, car stops means final velocity 0, okay. Initial velocity 0, final velocity 72 kilometer per hour, okay. Time taken is 5 minutes, okay. The question is asked acceleration and second question is asked displacement. First of all, before start the problem, you have to convert the all in SI unit. SI unit means MK system, meter, kilogram, second. Time is how many minutes? 5 minutes. 5 minutes means 5 into 60 seconds, okay. So 1 minute is 60 seconds. So 300 seconds as a time period. What about velocity? Velocity 72 kilometer is 1000 meter, 3600 second, okay. Cancel, 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 cancel. This will be 2. 20 meter per second. 20 meter per second in a SI unit, okay. First we will do the acceleration. Acceleration is equal to V minus U divided by T. V is how much? 20. U is how much? 0. T is how much? 300. Okay, cancel, cancel. It's 2 by 30. The answer is 1 by 15 meter per second square. We found the acceleration now. Again, I am going to find as a displacement. What we can take it displacement? S is equal to ut plus half at square. Whenever you want equation of motion, you can use it. It's a second equation, okay. Equation of motion, second equation. So S is equal to U is how much? 0. T is how much? We don't know. Plus of A is how much? 1 by 15. Again T is 300, okay. 300 whole square you can write. 0 into anything? 0. So half into 15 into 300 into 300. 2 divided by 300, 150. So 15 and 150 get cancelled, 10. So we'll get as a 3000 meter as a distance. That's going to be 3 kilometer as a distance, okay. Distance or displacement, okay. Both in straight line, distance and displacement will be equal. When the object moving in a straight line, distance is equal to displacement, okay. One more thing, whenever you want equation of motion, you can use it. V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. Whenever you require this, you can use this one in the formula, okay. Now I'll go with the problem number 6, okay. Problem number 6. This is a problem we are going to do. Initially 18, finally 36, time taken 5 seconds, okay. Again they asked acceleration and displacement, okay. 8th chapter, 6th problem right now I am going to do, okay. See, example problem. Example problem, 8th chapter, 6th problem we are going to do. What is the initial velocity? 18 kilometer per hour. What is the final velocity? 36 kilometer per hour, okay. What is the time taken? 5 seconds, okay. What is the question is asked? Acceleration and displacement. First we will do acceleration. Acceleration is equal to V minus U divided by T. Before start the problem, what we have to do? We have to convert both in a SI unit, okay. Initial velocity 18 kilometer per hour, no. 18,000 divided by 3,600. 0, 0 get cancelled. 18 table, this will be 2 times. This will be 5. 5 meter per second as the initial velocity. What about final velocity? 36 kilometer per hour. 36 into 1000 divided by 3600. 0, 0 get cancelled. And this will get cancelled. 10 meter per second. Now you can start solving the problem, okay. First we will calculate acceleration. Acceleration is equal to V minus U divided by T. V is how much? It's a 10 in SI unit. U is how much? 5. This is going to be 5. So 5 by 5, 1 meter per second square as acceleration. Then displacement, okay. Displacement, no. S is equal to ut plus of at square. Any formula you can use it. If you know time, you can use this one. Initially is how much? 5. Time is taken 5 seconds. Plus it is acceleration only because velocity increasing. Okay, it's going to be plus of a is how much? 1. T is how much? It's a 5 square. Okay, it's very very simple only. 5 into 5 25 plus 25 by 2. 25 by 2 how much? 5 square 25. 25 by 2 how much is 12.5. So 25 plus 12.5. So I'll get as a 37.5 meter as a displacement. Okay, right now we completed the problem number 6. Now I'm going to do with the problem number 7. Okay, it's actually very easy chapter. Okay, easily you can understand. Okay, example problem 8th chapter 7th problem we are going to do. Okay, now we'll read the question. So question is given as a brake is applied, the car it comes to the rest. Okay, it stops. No, final velocity 0. Started car, initial velocity 0. Stopped car, final velocity 0. Okay, starting means initial velocity 0. When the car is applies brake, it comes to end means final velocity 0. Okay, acceleration is given, time period is given. They asked you to calculate the displacement. Okay, or distance. Okay, so what is acceleration is given in the question? No, 6 meter per second square. Okay, now the car finally gets stopped. What about final velocity? 0. Okay, the time period taken for this problem is, the time period is 2 seconds. Okay, so now no, whichever equation you want you can use it. So I am using so they asked about the distance. Okay, ut plus of at square. We don't know what is u. If you are choosing this formula, no, we don't know what is u. You can go with another formula. V is equal to u plus at. When car started, no, it is getting accelerated, positive acceleration. When brake is applied, it will become negative acceleration. So here brake is applied. Okay, initial velocity something will be there, but final velocity 0. It is getting retardation. Okay, so a will become minus 6. Whenever retardation is there, you will use retardation as a negative. Okay, final velocity 0. Initially you don't know, a is minus 6, t is 2, so it is 12. Okay, so 0 u minus 12. From left side to right side you are taken, u is equal to 12 meter per second. So now we got u, then we can get as a displacement. So displacement formula, s is equal to ut plus of at square. What is u? U 12. What about t? 2. Okay, plus of a is how much? Minus 6. T is how much? 2. 2 square we can write. Okay, now 2 into 12 24 minus, this minus will come here, 2 times 6 into 2 into 2. This 2 get cancelled. 2 into 6 12. So 24 minus 12. 24 minus 12. The answer will get 12 meter as a displacement. Okay, now all the example problem we completed. Now I am going exercise problem. Okay, so exercise problem one by one we'll do. Okay, now book back problem. So book back, I am taken the book back. So one by one problem, book back problem we'll do. Thank you for watching my video. If you like my channel, please subscribe. If you want more video means you can go and see my playlist. Okay, so exercise problem, first problem. Okay, first we'll read the question. 200 meter dia, 40 seconds for each times completion will be there. Okay, so totally 2 minutes 30 seconds is moving. Okay, I will explain the question what is given. Okay, so athletics is moving in a circular path. Now what is the question we are going to do for exercise first problem? Okay, first problem. Okay, so totally 2 minutes and 20 seconds is going to move. Okay, it's a timing. So the circle is moving in a circular path, is running in a circular path also we can take it. See, each time is taken 40 seconds. The dia is 400 meter. Circle dia is how much? Sorry, 200 meter. Circle dia is how much? 200 meter, which is given in the question. Okay, so first 2 minutes 20 seconds, totally how many seconds? No, 2 minutes is 120 seconds plus 20 seconds, totally how many? 140 seconds. Totally is walking in a circular path. Okay, So each circle, no, he will take 40 seconds. Okay. So totally 140 seconds he is just moving. Now at 140 second, what is the distance? What is the displacement? Okay. We'll take it. He started from A. Okay. First circle. How many time he will take? 40 seconds. Second time, how many seconds he will take? 40 seconds. Third time, how many time he will take? 40 seconds. Totally 120 seconds. No, he will make us a 3 round. Okay. For 40 seconds, 1 round. First round, second round, third round. So 3 round. Again, he is totally 140 seconds he is walking. So again plus 20 seconds is there. Okay, for 20 seconds he will make us only half of the circle. Okay. So totally he is walking 140 seconds. Okay. 120 seconds he will make 3 round. Then 20 seconds he will make half round. Totally 3.5 rounds is going. Okay. Now what is the distance? What is the displacement? Okay. So he started from A, end with B. The distance between starting and ending we can call as displacement. Now what is the displacement? So displacement is 200 meter. Displacement very simple, 200 meter. Okay. Now distance. Distance, no. So he is totally making how many circle? 3 circle. 1 full complete circle. 2 3 circles. Each time circumference of circle. Distance is actual length of the path. First round, second round, third round distance. Okay. Then only half round is making. Okay. He started from A and end with B. Okay. It is a 40 seconds, 40 seconds, 40 seconds plus only with the 20 seconds. Half round means only half of the length, half of the circumference. Okay. So pi r, 2 pi r, 2 pi r, 2 pi r, 6 pi r. This 2 get cancelled plus pi r. So what I'll get? 7 pi r. So 7 into pi is 22 by 7. Radius is how much? Dia is 200 means radius is 100. 7 get cancelled. 2200. This is a displacement. Okay. Then we'll go with the next problem. Problem number 2. Okay. Exercise problem number 2. Now first we'll see what is given in the question. Okay. Problem number 2. This is a problem we are going to do. Joseph start from A, end with B, 300 meter is taken 2 minutes 30 seconds. Okay. And he turn back to 100 meter at the point of C is taken 1 minute. What is the speed and velocity A to B and A to C? Okay. So slowly we have to calculate. Okay. There are 2 conditions given. Okay. First we'll take it exercise problem, book back problem, 8th chapter, second problem we are discussing. He started from A, end with B. Only half condition will take now. 300 meter. For this process, no. What is the timing is taken now? 2 minutes 30 seconds. So what is the total time period? It's 2 minutes means 120 seconds plus 30. Overall 150 seconds is taken. Okay. Now what is the distance? What is the displacement? When the object moving in a straight line, distance is equal to displacement. Speed is equal to velocity. Because speed is distance by time, velocity is displacement by time, both is going to be same here. Okay. So what is the distance? 300 meter. What is the displacement? 300 meter. What is the time is taken? 150. Okay. So 2 meter per second when the object is moving A to B. Okay. First problem. Totally two problems is there in this. Okay. Now second he started from A to B 300 meter. He comes back to 300 meter. He stopped with the C point. Okay. Now what is the distance? What is the displacement? Okay. That is another question. So again I will explain the question what is asked. Okay. So tell me what is the question is asked. It started from A. He went to the B 300 meter. Again he came to the point C. Okay. 100 meter. So 300 meter. What is the displacement? Displacement starting and ending point. AC is a starting and ending point. 300 going and then coming 100. So remaining will be 200. Displacement is 200. For this one is taken 1 minute. This one is taken 2 minutes 30 seconds. Okay. So totally you have to convert in a time as a second. Time 2 minutes is 120, 120 plus 30 plus 60. Okay, so already we found 150 seconds is taken A to B. Again 1 minute is a 60 seconds, so 210 seconds is taken. Displacement is starting and ending point, it's 200 meter. Okay, velocity is displacement by time. What about displacement? 200. What about time period? 210. Cancel. Then 20 by 21, 21.0. So how many times we'll get? 9 times approximately we'll get. Okay, 21 into 9, so 9, 18, 189. So 9 times. Here it's going to be 1. Here it's going to be 9, 1, 0. Okay, what about next term we'll get? So next term, no. So approximately it is 4-5 times. Okay, so 0.95 meter per second as a velocity. Again, speed we have to find. Speed is distance by time. Okay, speed is distance by time. So what is the distance is taken? So going is 300 meter, coming back is 100 meter. Okay, distance is the actual length of the path. 300 plus 100, 400 meter as a distance. What about time period? Time period is same. So 2 minutes 30 seconds plus 1 minute. Okay, so 150 plus 60. 150 how we got? 2 minutes 30 seconds plus 1 minute. So totally we'll get 210 seconds. Okay, so speed is equal to distance by time. What about distance? 400 meter. What about time? 210. Cancel. So 40 by 21. That also you have to do. 40, 21. 21 will be 1 times. Again 3, 10, 9, 1.0. It is approximately 9 times. So 1.9 meter per second as a speed. Okay. Now I am going to do with the exercise problem. Third problem we are going to do. Okay. If you like my channel, please subscribe and share the video. Okay. Problem number 3. So what is a problem number 3 is telling now? A boy went to the school. It's going is 200 kilometer per hour. Coming back is 30 kilometer per hour. I want average speed. Okay, Abdul, average speed is the question. Abdul, average speed is asked. Okay. So going is 20, coming is 30. Okay, now we'll do this problem, third problem. Okay, see here, third problem, problem number 3. Exercise problem number 3. Okay, see here, it's a going to the school now. From house to the school is taken 20 kilometer per hour. Coming back 30 kilometer per hour. Okay, what is the average speed? The average speed is equal to, okay, total distance by total time period.